Okay, so these are the notes for right triangle trigonometry. Your essential question for today is, how do you solve a trigonometric story problem? All right, your main idea today is trigonometric functions, and a lot of this is going to be review from geometry. These are things that we cover, are things that are in one of the later chapters of our Algebra 2 book, so we won't be able to do a full chapter on it, so we've just kind of picked out some things to do for this. So on your sheet, you have these already typed out. So trigonometry is the study of triangles. A trigonometric function is a function whose rule is given by a trig ratio. A trig ratio compares the lengths of two sides of a right triangle. So you can only compare two sides at a time. The Greek letter theta, which is the circle, which is a 0 with a slash through it, is traditionally used to represent the measure of an acute angle in a right triangle. The value of the trig ratios depends on theta. Okay, so it depends on the size of the angle, not the size of the triangle. Okay. All right, so this is review from geometry. And so your teachers probably taught you about SOHCAHTOA to help you remember these. And so sine, not sin, sine of an angle theta is the ratio of the length of the opposite leg to the length of the hypotenuse. So if I were to write that over here in the symbols column with a formula, sine of theta is going to be opposite leg over hypotenuse, which if you look at SOHCAHTOA, S-O-H, you have sine is opposite over hypotenuse. Okay, so here's an example. This is the same picture for all of these. So if I'm looking at theta with respect to theta, this 4 is the opposite leg. This 3 is the adjacent leg, because the legs are the two sides touching the right angle. And the 5 is the hypotenuse. The hypotenuse is always across from the 90-degree angle, and it's always the longest side. So then if I were to find sine of theta for this one, remember sine is opposite over hypotenuse. So the opposite is 4 over the hypotenuse is 5. So the sine of theta is 4 over 5. It's that ratio. Okay, because we don't care about that adjacent. We only care about the opposite and the hypotenuse. Okay. Cosine of an angle, which is COS on your calculator, is the ratio of the length of the adjacent leg to the length of the hypotenuse. So that's the CA part down here, CAH. Cosine theta equals adjacent leg over hypotenuse. So that's the A and the H. So again, if I'm looking at theta, I only care about the adjacent leg this time and the hypotenuse this time. So then doing cosine of theta, the adjacent leg is 3, the hypotenuse is 5. So cosine of theta is 3 over 5. The last one is tangent, or tan on your calculator, but we still say tangent of an angle. Theta is the ratio of the length of the opposite leg to the length of the adjacent leg. So that's your TOA part. We care about the opposite and adjacent. So tangent of theta is going to be the opposite leg over adjacent leg. So then if I were looking here, I only care about the opposite leg of theta and the adjacent leg of theta. So tangent of theta is the opposite, which is 4, over the adjacent, which is 3. Okay. So that's SOHCAHTOA. Now, if you remember SOHCAHTOA, then the rest of it is going to be easy. Okay. All right, now, these you didn't cover in geometry, but you will in future classes, is cosecant, secant, and cotangent. Now, these are just reciprocals of one of the original SOHCAHTOA ones. So the cosecant, which is CSC for short, is the reciprocal of the sine function. So then cosecant of theta, and I'm going to put 1 over sine theta so that you know this means it's the reciprocal. So if I look back on the sine function that we just had, the sine was 4 over 5. So then just do the reciprocal of that, and that will be the cosecant. Whoops. So the cosecant of theta is going to be 5 over 4. Because all I did was take sine, 4 over 5, and do its reciprocal, 5 over 4, and that is what cosecant is. It's just the reciprocal of whatever sine is. So I don't recommend that you try and remember that's h over a or h over o or something like that. If you just have sine already, you know what sine is, then just do the reciprocal, and that will be cosecant. Then we have secant of an angle is the reciprocal of the cosine function. So secant theta is the reciprocal of cosine of theta. So if I go back here, cosine was 3 over 5. So then that means secant is going to be 5 over 3. Okay? And then cotangent of an angle is the reciprocal of the tangent. So cotangent theta is just the reciprocal of tangent of theta. So earlier, from the same picture, because this is the same picture, then I just do the reciprocal, which is going to be 3 over 4. So cotangent of theta is 3 over 4. So once you get SOHCAHTOA, sine, cosine, and tangent, you get those ratios from the picture, then you can find cosecant, secant, and cotangent by doing the reciprocals of all of those. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the reciprocal of tangent. Okay. All right, so let's do an example. And anytime you want to try these examples, then go ahead and pause it, you try it, and then you can turn it back on and see if you have it. So find the value of sine, cosine, and tangent for theta in the given triangle. Then find the values of cosecant, secant, and cotangent. Okay? So first what I'm going to do with respect of this angle theta, I'm going to label the sides O, H, and A. Opposite leg, adjacent leg, and hypotenuse. So with respect to this angle, 7 is the opposite leg because it's across from it. 24 is the adjacent leg because it's adjacent to it. And 25 is the hypotenuse because it's across from the right angle. Okay? So then let's do sine first. So TOA. So let's do sine first. So sine of theta is O over H. So I look at my picture, O is 7, H is 25, so it's 7 over 25. Okay. Now let's do cosine. So that's the cub part. So cosine of theta is A over H. So the adjacent leg is 24, the hypotenuse is 25, so cosine is 24 over 25. All right, now let's do tangent, TOA. So tangent of theta is O over A, so opposite over adjacent, so that's 7 over 24. Okay, so you SOHCAHTOA first and get your sine, cosine, and tangent ratios. Now, to do cosecant, secant, and cotangent, we're just doing reciprocals. So remember, cosecant is the reciprocal of sine. So that's 25 over 7. It's just the reciprocal. Secant is the reciprocal of cosine. So that'll be 25 over 24. And cotangent is the reciprocal of tangent. So that would be 24 over 7. Okay. So these last three are easy to find once you find your SOHCAHTOA, sine, cosine, and tangent. Okay. All right, example 2, find the missing side length for each. So on letter A, they want us to find CE, which is the length from C to E. So I'm going to make that my X variable. Okay, because that's what we're trying to find. Okay, then I say to myself, all right, so with respect to this angle 27, 18 is my opposite leg, X is the adjacent leg. So this is how we decide which one we're going to use. Because it doesn't tell us anywhere in the directions what to use. So then I have my SOHCAHTOA up here. You want to write that on your paper every single time, go ahead. So here I have the O and the A. We don't have the hypotenuse, which is okay. I just have the opposite leg, and then the adjacent leg is what I'm trying to find, and they gave me the angle. So then I'm using tangent for this problem. So tangent of the angle, which we know the angle is 27 degrees, equals opposite over adjacent. The opposite was 18. The adjacent is what I called X because that's what we're solving for. Okay. So now we have an equation that we can use algebra to solve. So first, you have to get the X out of the denominator because you can't solve for X when it's in the denominator. So I get this. X times tangent of 27 degrees is going to equal 18 because that cancels out. Well, now I need to get X by itself. So X times tangent of 27. To undo that, then I divide by tangent of 27. So we got to solve for X, which is what they wanted us to find, which is CE. So that cancels. And so now you're going to type this in your calculator. Now you do want to make sure that your calculator is in degree mode. So you hit mode, and you want to make sure that degree is highlighted here. If radian is highlighted, then you can go down, put your cursor on degree and hit enter, and then it'll highlight degree now instead of radian. If you're in radians, you're the wrong answer. That's something different to learn about in another class. Now I'm just going to type in 18 divided by tangent, and then I just hit 27. I don't have the degree sign because it's already in degrees now. And then hit equals. And we'll round to 2 decimal places. So we're going to do 1 decimal place, 35.3. And it really just depends on your multiple choice what they come out to be, but we'll just say 35.3, and it's meters. And so that's actually what CE is. So now instead of X, I'll put CE. That's what we said X was, and that's what they asked us to find. If you don't put these squiggle equal signs, this means approximately. That's okay because the multiple choice you could just pick which one's appropriate. They would only have 35.3 once. Okay. All right. So now you pause and try part B. Okay, on part B, they're asking you for JL, so that's my X. So then with respect to this angle, 18 degrees, X is now my opposite leg, and 34.6 is the hypotenuse. So when we're looking at SOHCAHTOA here, I have O and H, so that means I'm going to use sine for part B. So then write your equation is going to be sine of 18 degrees equals opposite, which is X, over hypotenuse, which is 34.6. Okay, now we do algebra to solve. So X is in the numerator, great. So X divided by 34.6, I need to multiply by 34.6 to get rid of it. Okay, so then I'm going to go to my calculator, 34.6 times sine 18. And that's approximately 10.7 when I round to 1 decimal place. So the label is millimeters. And then now I'll just take out that x because JL is what they actually wanted me to find. Okay. So this is if they want you to find one side length, I would name that side length your variable and then label the sides O, A, and H, which ones you have, and then based on the two sides that you have or that you're trying to find and what they give you, then you find SOHCAHTOA, which one it is, write the equation, then do algebra to solve. All right, example 3, find the measure of the angles given the trig ratio. So now we need to figure out how many degrees angle A is. Okay, so I'm going to rewrite that over here. Sine of A, we don't know what it is, but they gave us the ratio 2 to 3. Okay, so the inverse of adding is subtracting. The inverse of multiplying is dividing. The inverse of doing sine is what we call inverse sine, which looks like this. So I'm going to do that on both sides. It's sine with a little -1 exponent. So then what happens is these will cancel. So A is going to equal what you get when you type this in your calculator. So then how you find inverse sine is you just hit second and sine. So inverse cosine is second cosine, inverse tangent is second tangent. So here we need inverse sine because that was what the original problem was. And then we type in 2 divided by 3 and hit equals. And so with degrees, we'll round to the nearest whole number. So that's going to be 42 degrees. So angle A is approximately 42 degrees. Okay. There's no such thing as divide both sides by sine because this isn't sine times A. This is sine of A. So this is pretty glued together until you do the inverse of whatever this is here. Okay. All right, now on part B, we have to come up with the equation because part A, they gave us the equation. Now we need to get the equation on part B and then decide which one we need. Okay, so on part B, so with respect to this angle, we have the adjacent side and we have the hypotenuse. So when you look at SOHCAHTOA, which one is adjacent with hypotenuse? That's going to be your cut. So then we'll do cosine of x, because we don't know what x is, equals adjacent 13 over hypotenuse 17. Well, now we have our equation. Now we need to solve for x. So we need to get rid of cosine. So how do I undo cosine? Well, you have to do its inverse. You have to do inverse cosine. Okay, so those cancel out. We're left with x. And so now I'm going to type in inverse cosine, hit second cosine of, what was it, 13 divided by 17. And again, we'll round to the nearest degree, which would be 40 degrees. So that's the measure of that angle. Okay, so if you need to write yourself a note, when you need to solve for an angle measure, you must use inverse, which would be inverse sine or inverse cosine or inverse tangent, whichever one it is. In our original, we had cosine, so that means you do inverse cosine. Here, the original was sine, so we had to do inverse sine. If the original equation had tangent in it, so you had to solve for the angle, it would be inverse tangent. Now, again, that's only if they ask you for the angle measure. If they just ask you for the ratio, that's the one where you just do the fraction part. Okay, example 4. Find the measure of the given trig ratio, and it's telling us that the measure of angle C equals 90, because I highly recommend you draw a picture. So on part A, they're giving us tangent of A. I'm going to draw a right triangle. So C is the right angle, and you can put A at either of the acute angles. I'm going to put it up here. So then this could be your B. Okay. So here on part A, the tangent of A is 2 over 3. Well, looking at SOHCAHTOA, tangent is supposed to be opposite with adjacent. Here we go. So then that means that this number 2 is the opposite leg, and this 3 has to represent the adjacent leg. So since tangent of angle A is the number 2 over 3, that means 2 has to be the opposite leg and 3 has to be the adjacent leg. So with respect to angle A here, 2 is the opposite leg and 3 is the adjacent leg of angle A. Care about this angle here. Now they want us to find the cosine of angle A, what that ratio is. Okay? Well, for cosine, we have to have adjacent with hypotenuse. Well, I know the adjacent side is 3. So I already know that that number is going to be 3, but we don't know the hypotenuse number. So we need to figure out what that equals. So how do we find, if I know 2 sides of a right triangle, how do I find its third side? What am I going to use? We're going to use Pythagorean theorem. Okay, and remember that was where you did leg squared plus leg squared equals hypotenuse squared. I know a lot of people think of it as a squared plus b squared equals c squared, but you never know what the a, b, and c is. So here, the legs are the 2 sides touching the right angle, and the hypotenuse is across from the 90. So for this problem, I'm going to do 3 squared plus 2 squared equals x squared, because I don't know what the hypotenuse is. So that's 9 plus 4 equals x squared. That's 13 square root. And we're just going to leave that alone, okay, because that's not a perfect square and I don't want the decimal. So we're going to leave it as square root of 13. Okay, so then for the cub part, it's adjacent, which we said the adjacent leg is 3, over the hypotenuse, which is radical 13. This is not going to be a choice, though, on your multiple choice because you're not allowed to have the radical in the denominator. So this problem is reviewing a lot of old material that you've done before. And we've actually talked about rationalizing the denominator in this class. So how do I get rid of this square root of 13 on the bottom? Well, we have to multiply by the square root on top and bottom. So then this would now be 3 times the square root of 13. And that'd be the square root of 169, which is just 13. Because remember, when you multiply a square root times itself, you end up with just the number under the square root. So this is what cosine of A is, and that would be the choice that would show up. 3 over square root of 13 would not show up because it's not rationalized. You're not allowed to have radicals in the denominator. Okay? All right, so for part B now, again, still angle C is your 90 degrees. I could put A up here and B down here, however you want to arrange that. So now we're looking at B. We care about angle B, okay? And they're telling us that the cosine of B is 7 over 25, okay? So then if I look at cosine, remember that's adjacent over hypotenuse. So then that means this number is the adjacent leg, this number is the hypotenuse. The cosine is A over H, so this one is A over H. 7 is the A, 25 is the H. So then for B here, the adjacent leg is there, so I put 7 here, and the hypotenuse is 25, so 25 goes there. Now what we want to find is the sine of angle B. So I want sine of B is the answer we're looking for, what that ratio is. Well, remember, sine is O over H. Well, I know the H is 25, so I'm going to put that down here, but we've got to figure out what the opposite leg is, which would be right here. This would be your opposite leg, which we don't know what that is. Okay, so again, if you have two sides of a right triangle and you want to find the third side, you have to use Pythagorean theorem. This time, though, it's going to be, if I call this side I don't know, x, so x squared plus 7 squared equals your hypotenuse squared. So if you work that out, you get this, and then we subtract 49 and get this, square root, so you get 24. So then we figured out the opposite leg is 24, and since we need tangent, 24 goes on the top. So it's opposite leg over hypotenuse of angle B. So angle B, the opposite leg was 24, the hypotenuse is 25. So that's the answer you would look for. Okay. All right, example 5. When they tell you to solve the triangle in the directions, that means find all missing angles and sides. Okay, so on part A, notice we're missing the length of EF. So we're missing that. We're missing the length of FG. We're missing that side length, F to G. And then we're also missing this angle measure E. Okay, so those are the three things that we're missing. Well, let's find the angle measure first, because what did you learn about the three angles in a right triangle? Or in any triangle, actually. What did you learn about the three angles in any triangle? They must equal 180. So to find this one, I'm just going to do 180 minus 90 degrees minus 49 degrees, and that's going to give me the measure of angle E, which is 41 degrees. So if they give you two of the three angles inside a triangle, then subtract them from 180 because the three angles in a triangle must equal 180. Okay? All right, now let's find our side length. So I'm going to find EF first. So I'm going to make that my x variable. So with respect to this angle, 49 degrees, you can't use the right angle ever. So this angle they gave me, I could use the 41 in my picture, but I'm just going to use the angle they gave me. So with respect to this angle, what side does the x represent? Opposite. What side does 35 represent? Hypotenuse. So then when you have your SOHCAHTOA, which one is this with opposite and hypotenuse? Well, that's sine. So then I'm going to use sine for this one. Okay, so then I'm going to do sine of 49 degrees equals opposite, which we don't know what that is, over hypotenuse, which is 35. Okay, well, we multiply by 35 to solve. Type this in your calculator. So 35 times sine 49. And that's 26.4. So then x is approximately 26.4, which remember our x was the EF length. And that'd be centimeters because it was in centimeters. The side length was in centimeters. Okay, now I want to find the other side length, which I'm going to call FGY, because I already used x in this other problem. Okay, so with respect to this, the y is the adjacent, and then we have the hypotenuse 35. You could have used EF as your opposite, but just in case I made a mistake, I'm just going to use the given information 35, and then the side I'm trying to find in the 49 degrees. So then adjacent with hypotenuse, I'm going to use cosine for the second one. So cosine of 49 degrees is going to equal adjacent over hypotenuse. So then that's y over 35. All right, then we need to solve. So multiply by 35 on both sides. So then 35 times cosine of 49. So that's about 22.96. The 6 would actually bump that 9 up, so it's actually 23. So then y is approximately 23.0 centimeters. Okay, now we've found everything that we needed. All right. Okay, part B. Part B is slightly different. Notice this time they gave you two side lengths and you're missing one side length, which is XW. And then you're missing both acute angles. So we need to find the measure of angle X, and then we need to find the measure of angle Y. Okay. All right, so I'm going to find the side length first, right here. So if I'm trying to find the side length X, and I have two side lengths of the right triangle, how could I find that side length? Right, Pythagorean theorem. So we do x squared plus 31 squared equals 36 squared. So it's leg squared plus leg squared equals hypotenuse squared. All right, so then that's x squared plus 961 is going to equal 1296. Subtract that, we get x squared equals 335 square root, and you get to the nearest tenth, we'll get 18.3. And it's centimeters again. Okay. All right. Let's say I want to find angle y. So I'll just put that y degrees first. Okay. So with respect to this angle y, 31 is the adjacent leg, 36 the hypotenuse. So then a with h is cosine. So cosine of y degrees, we don't know how many degrees that is going to be your adjacent 31 over the hypotenuse 36. So I'm just using cosine because I have the adjacent leg to this angle y and the hypotenuse. Then remember, we just talked about a couple examples ago, when you're need to get rid of cosine, you're going to do inverse cosine. So that cosine cancels and you're just left with that variable, which is our angle. And so I'm going to type this in, inverse cosine of, what was it, 31 divided by 36. So it's about 30.6 degrees. Now with angles, we'll just round to the nearest whole degree. So then that would be 31 degrees. So the measure of angle y is about 31 degrees. And then to find angle x, I'm just going to do 180 minus the 90 minus 31. And that gives me 59 degrees for angle x. Okay. So solve the triangle means find all the missing angles and sides. If they give you two sides of a right triangle, do Pythagorean theorem to find the third side. If they don't give you one of the acute angles like they did on part A's problem, they gave you one, then just pick one, solve for it like we did here. And then to find the other angle, then just subtract from 180 and the 90. Okay. All right. Last two examples deal with applications. We have angle of elevation, which is when you're down on the ground looking up. Angle of elevation. So if I'm on the ground looking up at the airplane, that's an angle of elevation. Angle of depression is when you're on the top looking down. So I'm at the top of the cliff looking down at this sailboat. Okay. Now, actually, what ends up happening is if I draw this line of sight here and I draw this line of sight here, the angle of depression and this angle of elevation come out to be the same degree because we learned in geometry, you've got a z here, so these alternate interior angles will be congruent to each other. So that's a note on your notes there. That even though we talk about angle of elevation and depression, it ends up being the same measure together or each because of this. All right, example 6. So here's some steps I'll write off on the side here that we'll use for both story problems. So first, draw a right triangle. Because these problems, since we're in right triangle trigonometry, these will always be represented by a right triangle when you draw your own picture. Okay? All right, so let's draw our right triangle for you. Okay, then we're going to read the example and label our picture appropriately. Okay, so when the angle of elevation to the sun is 52 degrees, a tree casts a shadow that is 9 meters long. What's the height of the tree? So which of these side lengths is going to represent the tree? Which makes sense? Right, this is my tree. Okay, the tree is here. Then it makes sense that this is the ground. Okay, so then angle of elevation is always when you're on the ground looking up. So 52 degrees is going to go there. A tree casts a shadow that's 9 meters long. So the shadow is going to be on the ground. And then what's the height of the tree? So we want to know how tall the tree is. So that is your X. So whatever they want you to find, I recommend you make that an X. Okay, well, now we have to decide by SOHCAHTOA which one we're going to use and then write our equation and solve. So with respect to this angle 52 degrees, X is the opposite leg, 9 is the adjacent leg. So then that's going to be tangent. Okay, so now that was our step 3. Decide which trig ratio and write the equation. And then our 4th step will be to solve. Okay, so we decided it's going to be tangent. So then it's going to be tangent of 52 degrees equals opposite over adjacent, X over 9. Okay, now we just solve for X. So I'm going to multiply by 9 on both sides. So then we'll do 9 times tangent of 52. And we get 11.5. So it's approximately 11.5. And it's feet because I'm sorry, not feet, it's meters. Because the shadow was measured in meters, which is this side, so the other side of our triangle has to be measured in the same thing. Okay. All right, let's try last example, example 7. So the first step, before you even start reading these problems, you know it's going to be a right triangle. Okay. All right, now let's read it and see where we put everything. So a person snorkeling sees a turtle on the ocean floor at an angle of depression of 38 degrees. She is 14 feet above the ocean floor. How far from the turtle is she? Okay, so this is your ocean floor where the turtle is. So our little turtle is our little turtle. Oh, it's nothing like a turtle. Okay, there's our turtle, and then here's our snorkeler. Snorkeler's up here. Some bubbles. Okay, there's our snorkeler looking down at the turtle on the ocean floor. She's 14 feet above the ocean floor, so that means 14 feet goes here because that's how high off the ocean floor she is. And the angle of depression is 38 degrees. What that means is that her looking down here is 38 degrees, but that's not inside the triangle. So if I did my little Z technique here with alternate interior angles, this angle here is 38 degrees. And then we want to know how far from how far from the turtle is she? That's going to be the hypotenuse. That's going to be how far she is. Okay, let me put this in red. So that's all the pertinent information. Okay. Now, with respect to this 38-degree angle, 14 is the opposite side, x is the hypotenuse. So by SOHCAHTOA, which one is it? So, sine. So sine 38 degrees equals 14 over hypotenuse x. This is one where the x is in the denominator, so we have to get it out first. So we get this. Then we want to get x by itself, so then I need to divide by sine of 38. Okay, so then 14 divided by sine of 38 degrees is about 22.7. So she's about 22.7 feet from the sea turtle. Okay, make sure you're doing your Cornell note repetitions. That's going to help you. Then you're also going to do the right triangle trig and applications worksheet that's stapled right after these notes. And the answer key's on Schoology, so you can check and see if you're doing things correctly.